Hi guys, didn't realize I had my camera off. Sorry about that. How's everyone doing today? Happy Thursday. All right. All right. Evelyn. Okie dokie. So we did not quite finish yesterday, but hopefully you all posted your multiplication and division situations. And before we get too far into today, I want to see if anybody, I want to debrief that activity a little bit. Is there any brave team that says, can you just pull up ours and we can look at them because we're literally going to fix it for you. So any brave team want me to fix theirs?
Um, I don't know if my other two teammates want to, but go ahead and you could use
Okay.
Group 5.
Sure, why not?
Okay, so let me pull that up. And the rest of you, you can all pull up your Jamboards. So team 5, I'm actually not going to write on your Jamboard. I don't know unless you shared it with me, but I'm going to pull it up so I can see it and then we'll talk about it, okay? And if you have it a little bit wrong, it's okay. You can make adjustments to it. I am just going to give you credit for fixing it. I mean, for submitting it. And then I'm just going to give you feedback on how to fix it. Okay. Like, it's not going to be, I counted you off points for, what you did. We'll just kind of talk about it together. Okay. So let me pull up team 5's Thank you, Team 5. And everybody else should make sure they pull up that Jamboard, right, for their team. Somebody put in there that their thing is running really slow today. Mine just decided to start going really slowly. So, which is lovely. Okay. Team 5. Okay, let's start. I'm just going to share my screen maybe, if I'm competent in that area right now. Okay, can you see my screen? I hope. Please tell me yes. Okay, it's team 5. So let's just look. Equal groups, let's start there. The first one was done for us, Joanne's Bakery. They also said that there are 25 cars in a parking lot, so B was equal groups. They also said K, G, and N were all equal groups. And is there any team that thought any more was equal groups or any less was equal groups, or do we agree, disagree? What do you think about team 5's input here?
What about L?
What about L? So L was Jim invited his friends over to play. He has 30 toy cars that he wants to share equally among his friends. How many toy cars will each friend get? Where do you guys put L? Let's see. Oh, maybe L got hidden behind something else. Team 5, did you guys have L somewhere? I don't see it on your board.
Hold on, let me look at it real quick.
Yeah, because it might be covered up by something. But I agree with, does anyone else agree with, I don't even know who that was who said that before. Vanessa. Thank you, Vanessa, who said L should be in equal groups. I would say it's in equal groups. Brianna says thumbs up, yes. Anyone else think L should be in equal groups? I put it there.
So it looks like we didn't. We
Okay.
skipped L.
That's okay. Just add it on now. So you have it, right? So you're good. So, and I'll give you feedback on these Jamboards too. I just wonder, is there any of them that you did not think should be in equal groups out of the ones we just listed? So we had A, B, K, G, N, and L, right? K, G, N, and L. Anything else that should go there or should not go there? Questions, concerns? Now, some of those are multiplication and some of those are division, right? And that was later that we talked about which ones were multiplication and which ones were division. And when you wrote out your problem, I think that's when it helped you figure out if they're multiplication or division, right? Nice. So multiplication, did you say A and B were multiplication? And then division were G, K, L, and N? That sound good? Okay, excellent. How about for rates? Rates, did you say you have F and you have C and that's it? Anyone have any other ones? Nice, nice. One of them's multiplication, one of them's division. Anyone need clarification on that? Okay, and I love this team, Go Team 5. I love all your labels on your units. If you don't think about it, you're real fast and you just write 12 times 3 and you say 36 and then you put your units on the very end. The reason I like to put my units throughout the whole thing is then they make sense where they came from, right? Like, how did we get miles per hour? Right? Oh no, actually that one, let's look at that one. How far did Pedro break? Oh, that's 12 miles per hour times 3 hours. What unit should be right here on the end? right here. What unit should be here?
That one should just be miles. 'cause
Yeah,
it's how-
this, there you go. That one should say miles. So $12 on oranges divided by $2. Okay, be careful. $2 per, this should say pound, right? That should say pound per pound of oranges because it's not per orange. $2 an orange, I will sell you oranges all day long, right? Okay, and then that would be 6 pounds of oranges. So what's nice is that when we write out all these units, we can see where these units come from. Okay. And then comparison problems. J and D, and again, one was multiplication. One should have been division. Did you see on D? D should be division. How many of you agree D should be division? Yeah, and by the way, baby Pedro is a baby. So if I'm 75 inches tall, Pedro better not be 225 inches tall. Do you know how tall that is? That's insanely tall. So this one right here should be division, right? Okay, so make sure that's division. Excellent. Questions on that? Nice. There was an error saving this, but we're good. Okay. Let's look at these. We'll look at them more closely. I just wanted to make sure we had them categorized at least correctly. For area, did you have the same ones they had? M, which was a division problem, right? I, which was a multiplication problem. H, now if you put H in a different category, it's okay. If you put H in equal groups, that's fine too. If you put H in area, that's fine too. Either way, the reason people put it here is because it says a rectangular arrangement, right? So that's why if you put it in area, okay. And then combinations, there was only one of them. Okay, those are a little trickier to write for division, right? Did anyone try to do their homework and try to write that one for division yet? Not this homework, but you have other homework where you write some of these problems. Did you see that? You write a multiplication and division problem for each one of these types, and it's really good for you to practice that because they're harder than you think to write, right? You don't realize what you're really implying. Okay. Sorry, I was ignoring my chat. I don't know if anybody's been chatting over here. Thank you. Sorry about that. Oh, okay, good. So I just caught up with the chats. Everybody okay with how we categorize these? Any questions, concerns?
I have a question.
I'm ready, Betty.
I don't know why it's not like grasping in my brain. I'm just confused on equal groups and combinations. Like I don't know why I can't distinguish them. Like,
Oh,
for some reason they both sound the same to me. And when I was reading the problems and I was trying to categorize them, it was just I don't know. I don't understand why I can't grasp onto the difference. Like, they just seem the same to me.
no, you're totally fine.
I
So
tried different ways and
combinations are pretty easy to distinguish because combinations are usually something that you would draw a picture of with a tree diagram, right? Where you would have like, my favorite analogy for this combinations is, did anyone ever watch the show What Not to Wear? Did anyone ever watch that show? Betty, did you ever watch that show?
no.
Okay, so here's the show. Somebody who claims to be your friend says you dress terribly. They send in a video of how poorly you dress to this TV show, right? The TV show picks you because apparently they agree and think you dress terribly. Bring you on the show. The first thing they make you do is throw out all of your clothing. Yeah. How crazy is that? Yeah. They throw out all of your clothes because apparently you don't know how to dress yourself. Then they take you shopping and tell you what you should be wearing. And by the way, I don't think this show really works. But anyway, that's a separate issue. Now, at the end of the show, and this is why it reminds me of combinations. If you're like, what is she talking about right now? at the end of the show, they bring out this rack of clothing, right? That they spent all this money on. And then they tell you, oh, Susanna, whoever she is, right now has 120 outfits. And you're like, there are literally like 3 pairs of pants hanging up there, 2 skirts, 4 shirts, and 3 pairs of shoes and a scarf or whatever, right? So what they're doing is they're using this combination formula and they're just multiplying the number of pants times the number of blouses times the number of shoes and saying all of those are different outfits. Now, I don't know who was writing this show, but if I just change my shoes, it is not a whole new outfit. I'm just saying that is the same friggin' outfit, right? Or if I just put a different scarf on it, it's the same outfit. Like, stop that. So that's how they kept getting those really big numbers. If you've ever, okay, so this is what happened. I watched that show because it was very insulting. And I was like, wait a minute, what math are they doing? Oh my gosh, they're doing the fundamental counting principle. They are literally just multiplying these things together. So that's how I spot a combination problem. Anytime they're trying to talk about, I have this many flavors of ice cream, I have this many types of cones, how many combinations can I have, or how many different one scoop ice cream cones can I make? That's a combination.
Yeah, because it's
Equal
like it's in the name, which obviously, but it's like I don't know, I just couldn't. I mean, you kind of made it a little more clear.
and
Um,
equal groups is a little bit, equal groups is much more common than combinations. Equal groups are things like when they say, it, okay, have you ever made goodie bags for a party?
yes.
The death of you? Yeah. Okay. So you make goodie bags for a party or your kids at school, right? And you're like, okay, how many? I have 24 kids in my class, right? And I'm going to go buy party favors and I want them to have erasers, right? And so, well, the erasers are kind of small and they're going to be annoyed if they only get one tiny eraser. So I have to give each kid 2 erasers. So now I have 24 kids. They're each going to get 2 erasers. So now I have 48 erasers I have to buy. And then you look at the dollar store and they come in packs of 6 erasers and you're like, "Oh my gosh, how many erasers do I need to buy?" Yeah, it's insane. So equal groups are when you're sharing things out or you're distributing like think candy into bags, something like that. Does that help a little bit, Betty?
Yes, it does. Thank you.
Okay. Anyone who's made goodie bags knows that pain right there.
Yeah, I've done
Yeah.
it for my students, like right now. Yeah.
Yeah. Yeah.
Thank you.
Yeah, no worries. Anything else on this assignment? Like I said, I'll give you specific feedback on it. I just wanted to make sure we knew how to um, categorize these
Do we have,
before you.
sorry, do we have like any resources where, like, because I learned a lot from examples. Is there like somewhere in our like slides that has examples of those problems? Like a lot of
Probably not a lot of them, but literally here's a nice way to do it is if you just like go to a worksheet place. I really like Common Core worksheets. That's a great website. So if you just search Common Core worksheets multiplication, you'll pull up a multiplication worksheet. You'll see all these examples and you'll go, oh, that's definitely equal groups. 9 times out of 10, they write equal groups problems, just so you know, because they just don't write the variety. That's why we want to practice writing some other ones. Okay. All right. So any other questions on this activity? I know you had other things like how did you decide if the problem is division or multiplication? That was harder, wasn't it? Like not to do the problem, but writing down how you decided to do it. You're like, because I did the problem, right? Because I found the answer by division. So I guessed it was a division problem. Right. I see some answers on this groups. They're like, oh, it was the words that helped me. Right. The words like all together or the total, you know, or these types of things. Whereas when you were doing the division ones, they said each, right? Or per, or things like that. Sometimes on units, if the area problem was in square units, right? They gave you square units and then they asked you to find the length, and that was the width was in regular units. Well, how would we go from square units to regular units unless we divide, right? There's no other way to get there. So a lot of times it's just the wording in the problem. All right. Okay. Any other questions on that? Good questions, by the way. All right. So we got through that activity, and then there was so much more. One of the biggest things is multiplication and division sentences. So does anyone remember the multiplication way of thinking of it? What's the first number in the multiplication represent compared to the second number in the multiplication?
Isn't the first one? Oh, how many groups there are?
Yeah. And then what's the second one, Amanda?
How many are in the group?
Yeah, exactly. And I like copies. So if you get annoyed with me saying copies, it's okay. I'm still going to say it. But you can say groups. It doesn't bother me. I don't mark people down for copies, but I do test you on copies, right? Just so you know. So the first number in the multiplication sentence is the number of groups or copies. The second number is the size of the copy, right? And you could apply that to any of those that we just talked about. That was just me coming into our meeting, just so you know. And you could apply it to anyone. Like I always think of the tires in the parking lot, right? So the tires on the cars. If there's 4 tires per car and there are 25 cars, then I'm going to multiply those two. But what we didn't talk about was division. And I want to show you this division connection. There we go. So just what Amanda just said, the first number is the number of groups, the second number is the number and the amount in each group. If you look at division though, sometimes we divide, the first number is always the dividend, right? So the dividend, that's what we're trying to split up. Sorry, hold on. I lost my people. Jessica's trying to come in the meeting and I can't even figure out how to get her in here. Can you see my iPad? Thank goodness. Okay. Let's see if we can let Jessica in the meeting. That's so sad. Okay. I don't know how to get her in here.
Back in. I don't know why I just got kicked out for some reason.
Okay. And I don't know why. Oh, that's why I couldn't let you back in, because you weren't there anymore, like in my waiting room. But I was like, I feel so bad. It popped up and then it went away. Okay, good. Glad you're here. Okay. So notice that division problems can be written differently. Sometimes the number you're dividing by, which is called the divisor, is the number of groups. And sometimes it's the amount of in each group. Okay, so that's different than the other problems we've looked at so far. Can you think of any of the problems, if you're still looking at your Jamboard, are any of those problems the ones you can think of? Find a division problem and then classify it as, is it this first one where it's the first number is the number of groups and the second one is the amount, sorry, the divisor is the number of groups and the quotient or the answer is the amount in each group, or the other scenario where the divisor is the amount in each group and the quotient is the number of groups. I'm so sorry if somebody was talking because I think I just had a tech problem. Can you guys hear me? Oh, thank goodness. You're just not
Yeah.
answering me. Okay. How about this question? The question Nicole brought, it's K. Nicole brought 48 cookies to school for a birthday party. She plans to give 2 cookies to as many people as she can. How many people will get to eat her cookies? So is that the first one where the divisor is the number of groups, or is it the second one where the divisor is the amount in each group?
Is it the number of groups?
So it says she plans to give 2 cookies to as many people as she can. So we're talking about our divisor, which is the number we're dividing by. Is that the number of groups or is that the amount in each group?
Amount.
It's the amount in each group because it's 48 divided by 2, and the 2 is this, the amount in each group. I lost my Apple Pencil. So right here. If we had our 48 divided by 2 equals, and we know our answer is 24. In our problem, the 2 was the amount in each group because each person was going to get 2 cookies. Does that make sense? So do you see, and then can anyone find one where it's the number of groups?
Was the one with the toy cars and his friends? The number of groups.
Yeah, because you're trying to figure out how many cars each friend gets, right? So 30 toy cars, he wants to share them equally with each of his, maybe I should read it. He has 30 toy cars that he wants to share equally with his 6 friends. So his friends are each their own group. And then the number of cars is the amount per group. So this is L from the last activity. So do you see how that's different? So division behaves a little bit differently than multiplication. So it's a little bit harder for students to understand that. Okay, that model, which is part of the reason that division using 0 can be tricky, which is what we're going to talk about on Monday, right? What if 0 is our divisor? What if 0 is our dividend? How does that change our thinking and our problem, right? Because most of you just memorized that or tried to memorize it, right? And you don't really understand it. So, and we're going to try to apply it to something that makes a little more sense to us. Okay. So, let's talk about this problem right here. Maria has 5 bags of oranges. Each bag has 7 oranges. How many oranges does she have? So what type of problem is this? If you look at this, this is a kid's work, right?
Equal groups.
Yeah, it's an equal groups problem and it's multiplication, right? So if you were going to write the multiplication sentence accurately according to our model, how would you write it? And this is for anyone, not just Tyler, who just was so good to answer.
Would you write it so 5 would be the number of groups, correct? And then 7 would be the amount, so it'd be 5 times 7 equals 35.
Very nice. So it's 5 bags times 7 oranges per bag would be a total of 35 oranges. Very nice, because think about their picture, right? Their picture shows it just like we need it. We have 5 groups and there's 7 in each group. Very nice. Excellent. Okay. Get this one. So this student said, I started at 20 and I jumped back 4 spaces. I did this 5 times to get 0. So this is the same type of problem, right? The same type of problem because it's division. So, but what are they doing when they did this? Are they thinking that the 4 is the size of the group or the number of groups, or does it matter? Tell me what you think about their strategy here.
I think their strategy, the groups don't really matter, as it's kind of like that one subtraction strategy with the number line.
Yeah, it's very similar. This is what it looks like, right? So they started at 20 and they just went back in groups of size 4, right? So their groups were size 4. So they had 5 groups of size 4. Okay. If you interpret it differently, it becomes problematic, right, for your explanation. But I love the different strategies, the number line strategy. I love this explanation. 20 divided by 4 equals 5 because I did it right here. Okay. So this, what is this model showing? What did this student show?
The number of groups would be 4.
The number of groups is 4. The size of the group is 5. Yes? And compare that to here. This one, the size of the group is 4. The number of groups is 5. Yeah, different. It gives you a different picture. That's what we were talking about with multiplication. If we reverse that multiplication, we're going to have a different picture. Okay, here's this one. Goes back to the same one the first one did. 5 bags of oranges. Each bag has 7 oranges. How many oranges does she have? What do you think about this picture? Get your answer ready in the chat. What are you going to say about this picture? Did this student, how did they model this problem? Does their picture show the problem? Everybody should be writing in the chat. We're going to hit enter in a couple seconds, but not yet. Get your answer ready. All right, are you ready? 3, 2, 1, go. Nice. You guys just couldn't wait. You were so excited to answer. I'm going to do 3, 2, 1 chats all the time. It's more than I've heard in a long time. Okay, now read through everybody's and pick one you really like. You think they really understood what was happening there, or they explained it really well.
Oh, I think Madison did good.
Oh, Madison's. Let's read Madison's.
I agree with Madison. really detailed and made sense.
Yeah, Madison says, no, it does not, because they're saying that there are 7 groups bags of 5 oranges according to their drawing. So they modeled 7 copies of 5, not 5 copies of 7, right? Very nice. No worries. I understand tech issues. We're good. Okay, so if I had a picture of this on a test for you, and I said, tell me the multiplication problem that they're showing here. If you wrote this, even though the answer is correct, that is not the multiplication problem they're showing, right? They're showing 7 times 5. Even though they should have been showing this, what they really showed was this. Does that make sense? Do you see how a consistent model from the teacher is really important? Because this will really help our students' problem solving abilities. And some of you are like, I seem like this, I may have done this really young, but then somewhere maybe around 5th, 6th, 7th grade, it fell out of my head and things started going crazy, right? And that's probably because your teachers might have been less consistent with the model and less consistent at connecting it. I worked in 6th grade classrooms a lot with, I wouldn't say, okay, so on a test, would I mark it wrong? It depends on if this is a kid, you assess kids a lot differently, right? So if you're a kid, you would probably be having a conversation with them and ask them, okay, so what do your lines represent? And usually when you ask them those kinds of questions, they'll say things like, oh, the lines are the oranges. And you're like, okay, the lines are the oranges. So what are the numbers on the lines? And they'll say something weird like, oh, those are the bags. And you're like, oh, okay. But almost every time when you ask them to talk through it, they go, oh, oops, I made a mistake. And they'll find their error right away. And if that happens, you just say, perfect, can you redraw your picture? Or you might have some smarty aleck in your class that says, I didn't want to count by 7s, right? I didn't want to do 7s. Counting by 5s is easier, right? Right? You have a smarty aleck in the class that's like, why would I do 5 copies of 7 when I could do 7 copies of 5? And as long as your student can say, well, using the commutative property of multiplication, I can multiply these things in either order and I get the same answer. So I decided to be more efficient and do 7 copies of 5 instead of 5 copies of 7, right? If your kid can say that, boom, you're good, right? They knew what was happening. If the assessment tool is trying to see, can they model the picture of it, that's a different question, right? Because they did not model the picture accurately. But that's a great strategy, right? How many of you would think of counting by 5s instead of wanting to count by 7s? Yeah, all of us, right? So you just have to remember. Now, I brought up that word commutative property. The other day we talked about it, the commutative property of addition. And it was because those two things are named the same thing, right? Add-end, sum. And there was no commutative property for subtraction, right? Why not? Why is there no commutative property for subtraction? Anyone know? What are those things called? They're not add-ends.
They're not the same names.
Yeah, what are they?
Subtrahend.
Nice. The minuend is the first one. The
Yeah.
subtrahend is the second one, right?
Yeah.
Very nice. And I think that's kind of easy-ish to remember because sub would be underneath, right? Or after subtrahend. Excellent. Do you know what they're called in multiplication, the two things that are being multiplied together?
Isn't it dividend and divisor?
Those are division, right?
Would it be product?
Good. Dividend, divisor are division. Product is the answer after
Yeah, never mind.
multiplication. Love that. Yep, product is the answer after multiplication. Factors, Michaela, good job. Factors are what we multiply together to get the product. Now, some crazy person at one point called them multiplicands and multipliers. Have you ever heard of those? Yeah, just throw those out. Those are more confusing than helpful, in my opinion. So if your textbook says that, good luck, right? Like scratch it out in your kid's textbook. Okay, so I like factor because that connects it to addition, right? Multiplication is just repeated addition anyway, right? So it makes sense that those two things would have the same word because then I know that the commutative property for multiplication applies. I can change the order and I haven't changed the answer. Okay. We can make, these are some ways we can make sense of multiplication for our students. They're called arrays, right? So just a combination of rows and columns. So 3 times 5, 3 rows, 5 columns. 3 rows are usually horizontal, columns are vertical. That's how we make sense of things. If you think of Excel, if you've ever made an Excel spreadsheet, do I want to add a row or add a column? Right? That's kind of a nice way for you to remember it. Okay, so I'm going to put you in breakout rooms, hopefully. Did you all change your names, I hope? And I'm giving you a Jamboard. And seriously, I cannot remember. I better click on my Jamboard first. I can't remember if it's for all of you or if I need you to copy it. I can't remember at all. One second. I was just in it. Where did it go? Annoying. Okay. And I'm going to want you to do this activity with your team. And it's not, I don't think it's too hard. I don't know why that link jumps around. Sorry, speaking of tech issues, whoever that happened to, it just cursed me. So, okay. Okay, so there's the Jamboard. I just pulled it up. I'm pretty sure you have to make a copy of it. Yeah. So, but if you look at the Jamboard, you can see on the very first page, it shows you how students partition an array. So some people call this the area model because it's a rectangle. And they want to split things up. So if you look at Arya and Ben, they were doing 8 times 6, but 8 times 6 is, or 6 times 8 is one of the hardest multiplication tables for kids to know, right? I don't know why, but it's hard. Probably some of you, it's just hard to remember. So Arya, if you look, Arya decomposed the 6 into 5 and 1. And so said 5 times 8 is 40 and 1 times 8 is 8 because she knows her 1s and her 5s much easier than she knows her 6s. And then Ben split the 8 up, right? Instead, because he must know 6 times 4. Okay. So it says write equations to show their thinking. So see if you can write out the math symbols that show their thinking. Okay. So, and then there's some questions on the little sticky notes to help you. And then I said, okay, draw some arrays for some other basic math facts like 7 times 8 and 9 times 4. And then I have a bigger one, 5 times 26. How will you partition it? So I'll get you started on the 7 times 8. Anyone have an idea of how they would do 7 times 8? how would you like to split up 7 times 8? I did this. Oops, sorry. I was writing 40 plus 16 is 56. Okay, right? That's how I split it up. There's lots of other ways you could have split it up. Okay, does everybody know what their task is?
Yeah, I have a question though.
I'm ready.
So I was actually looking at the more, I think it was the multiplication and division,
Mhm.
and it shows the array kind of visual method, and it says sum. Like they say, it says sum at the bottom for like each row and column.
Mhm.
Would you be going over that as well, or? 'Cause I'm confused into that.
You're confused at how you're supposed to do it?
No, like I get how to do it. Just it says the sum for each row and column below, like once you have already set it up. Does that make sense?
So what's your question?
So my question is like, will you be going over the sum of like towards the end after you set up your array visual problem? Does that make
Wouldn't
sense?
the sum be, for example, here 40 plus 16? Is that what you're talking about when it comes to sum?
Yeah, but on the more it's a little different. I guess I can ask you about it.
And just send me which problem it is and I'll look at it while you guys are working on your jam
Okay.
boards.
Okay.
How's that? Does that sound good? Okay, so I'm putting you in your breakout rooms. You guys should all, pick who's going to make the copy, who's going to do that, and then just think it through. I really want you to think about how to write the math because I did not write the math out for you symbolically because that's going to bring up a new concept for us. Okay. So think about how you would write that out. Okay, and call me to your room if you need help. Hi, Evelyn. Hello.
Sorry, I was muted.
Okay, so first ones back have to share their screen. Sydney, your team has to share a screen. So I know it's rough. So Sydney, can you share your Jamboard? Just share it on the screen so we can see what you guys were doing. You're muted, but that's okay. If you were just complaining, like, why did I have to share? Next time I'm not coming back, right?
I was asking, do I just click share screen? and
Yep, just click share screen and then pick wherever your Jamboard is on the, you'll see windows pop up.
then- Okay. Oh gosh. Oh. Okay. Jamboard. Is it working?
Yep. Yay. Look, so this is team 3. So
Yeah.
team 3, Sydney came back real fast. So I was like, you win the prize. You get to share your screen. So now the rest of you are like, oh, we're never coming back. And then tomorrow I'll make it the last group that comes back has to share their screen. So you'll never know what I'm going to pick. So just be prepared to share your screen all the time. And I just wanted to see how far you were getting because some of you, I think, were a little confused. Some of you were, who knows, still struggling writing on this Jamboard. I think I'm 99.9% sure that Jamboard has an app for your phone. So if you want to, you can download the app. And if it's easier for you to write, you could do that. So, because the pain with some of you to write. So excellent. So here we have this team. And then did you do some of your own on the next slide?
We just did all the slides.
You're good. Let's stop right here. Let's just look at this for a minute.
Wait, do you
So,
want this one or the first one?
yeah, nope, I want this one right here, the one you're on. Slide 2, I think you're on. So
Yeah.
leave it there. So everybody can see it, right? So they decomposed the 9 into 4 plus 5, and then they did 4 times 7 and 5 times 7. And so they got 28 plus 35. And they answered their question by splitting larger numbers. We can easily multiply and add our products to get a sum. Now, did this look like the distributive property to you guys? Do you remember the distributive property? Okay. I'm getting some maybe shake their head, maybe some roundabout. Okay, good. Some people do. The distributive property, if I gave you a stack of papers and said, distribute these to the class, what would that mean?
Give it out to each person.
Yeah, give it out. And you can't see people you don't like. You have to give it to everyone, right? That's exactly what the distributive property means. So what they did was they gave the 7 to both of the parts that they decomposed 9 into. So they did 7 times 4 and 7 times 5 did the sum. Now, you might be more used to seeing something like this. This is going to look weird just because I'm going to write on it, you know? So it's not really on your Jamboard, but some of you wrote it like this. You would feel like that looks more like the distributive property. Yes? Can you see where I typed on there?
I don't see anything.
We're still
Really? You
looking at
can't?
Sydney's screen.
Yeah, I can see Sydney's screen too. I just typed red in a text box right underneath it.
No, there's no.
No.
That is bizarre. Maybe I just have a huge delay. Who
Did you
knows?
press enter?
How about now?
Yep.
There we go. I had to get out of that text box. I couldn't even press just enter. I had to get out of that text box. So does that look more like the distributive property to you? 7 times 4, 7 times 5. Yeah. Does that seem familiar? Yeah. So good. Excellent. Well, very nice. And they split it into 8 times 4. They did 4 times 4. And then that was just a lot of 4s there. Excellent. Very nice. Sydney, you can stop sharing now. Okay. Does another team want to share theirs so they can show us their differences or choices? Don't everybody volunteer at once. I know.
You can.
Okay, I'm ready, Vanessa.
I have to share my screen, right?
Yeah, somebody in your team does. Doesn't matter if it's you.
Okay, let me try.
And if you're nervous to share your screen, we're in week 3. We should all be able to share our screens now. And if
I
you
can share my
can't,
screen, Vanessa, if you don't.
no shit, Vanessa's gonna figure it out.
Yeah, I think
You got
Yeah,
this,
we can
Vanessa.
all figure it out. It's okay, I promise you. If it takes an extra minute, it's worth it because then when you're in your breakout rooms, it'll be easier.
Give me a second. I lost my Jamboard.
And you also feel some sympathy for me now or empathy for me now when you try to share your screen because I do it all day, every day, right?
Well,
How you doing, Vanessa?
I don't know where my Jamboard went. I don't know what happened
Is
to
it in Chrome or what did you do it in? Because if
I'll
you
pull it
click,
up again. Sorry.
you're good.
Wait, how do I pull it up?
There's a green button with an arrow in the middle of the bottom of your Zoom screen that says share screen. And
Yeah,
click share screen, and then it'll bring up a window of all the things that are open, including like a whiteboard, whatever. Click on the one that looks like your Jamboard.
I don't know where my Jamboard went.
Okay, well just click share screen and click desktop, and then we'll find it for you.
Share screen.
I'm
sharing screen, desktop.
Yep, just click desktop.
I need to do something with the security.
And then click share.
Can you see now?
No. What's it saying now on your screen?
It said I had to update my, oh, I can see now.
Okay, perfect. Now we can see it's coming up. Perfect. So now maybe drag that security window out of the way and see if you can find your Jamboard. Oh my gosh, do you need to plug in your computer? Because I'm terrified that it says you're going to die.
I'll plug it in after.
Okay.
I don't know where the Jamboard went. Oh, found it.
There you go. Perfect. Very nice. So they did 6 times 4 and 3 times 8. And so they decomposed 6 into 5 and 1 and decomposed 8 into 4 and 4. Nice. And so just like I just wrote it on there, you're going to rewrite this as multiplication. You did do 12 plus 12 equals 24. But mathematically, what you really did is 3 and then parentheses 4 plus 4, right? Equals 24. That's what you did. And on this one, you did 4 times 5 plus 1 in parentheses. Okay, good. So Vanessa just passed the test. She can now share her screen.
Yay.
So excellent. Okay, so now I'm going to share my screen because I want to show you something. I can always kick you off sharing, so you don't even have to worry about it. I can always make, but it's the same button that you shared with right at the top of your screen. It should say stop sharing. And if you didn't share today, you're definitely going to be sharing soon. So here's one. I made the array for you because I thought it'd be hard to break up 26. Did anyone try this on their Jamboard? Nice. Tyler did. Amanda did. A couple people did. Just tell me how you split it up. You can actually write on this if you want, but I can write on it for you too. So how did you decompose either 5 or 26?
We split 26 up into 10, 10, and 6.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this was 10, this was 10, this was 6. Did you leave the 5 alone?
Yeah.
Nice. So then this was still 5. So this would be 50, 50, 30. Right? And so it's a nice way to get that. Now you could have been even less decomposing, and you could have just split it up right here and said this is 20 and this is 6 because 5 times 20 is 100, right? And then that would be 30. So you could do it that way too.
But why do it the easy way?
Remember, you just want to do it whatever way is best for you, because you'll have kids do this and you'll also have kids do this and you'll be like, why did the child do this? Okay. You'll have a kid who does this. So they'll go 2, 2, 1, right? And then they'll go, maybe they'll go 10, but maybe not. Maybe they'll go like this. Yeah. And you're like, what on earth is happening? But that kid might really only know the multiplication tables of 2s and 5s. So they might feel more comfortable just doing that. So this was 5, 5, 5, 5, 5, and 1. So they would get all these would be 10s because they really love counting by 10s, right? These would be 2s. That's a 1, 5, 5, 5, 5, 5. I've seen this happen in class. And the kid at the table next to him is like, why did you do that? Because you have them work by themselves and then you have them share their work with a partner. And they'll both have the exact same answer. And the kid sitting next to him, instead of you coming around and telling them, the kid sitting next to them will go, didn't you notice that you could have just grouped these as 10s and these as 10s and made your life a lot easier? And then the other kid most of the time will go, yeah, but I like it my way anyway. And then the next time, maybe they'll pick a more efficient strategy, but it didn't come from you as the teacher. It came from another kid, right? Especially if you've cultured a really good environment in your classroom where your students are able to respectfully disagree with each other and help each other out. It's really, really an amazing thing that happens. Okay. So the other thing I wanted you to think about, and we'll for sure think about this later, but I want you to think of how you would decompose. Let me find a problem for you. Either of these problems, just do it. You can do it on your Jamboard if you want, so you can see each other's work while you do it, but try either 25 times 12 and 14 times 5, and you can use whatever decomposition strategy you want. So do either problem, you don't have to do them both, and do 25 times 12 or 14 times 5. Just try it. All right, does anyone have a strategy? They can just describe it. They don't have to share their screen. Anyone? I don't know. Hannah, I'm ready.
I did 25 times 12.
Okay.
I kept the 25 and I broke 12 into 3 4s because I know that 25 times 4 is 100. So that just gets you 300s.
Nice. And we could write that mathematically. We did this.
Yep.
Right? Excellent. Okay, did anyone do 14 times 5?
I did.
Nice. What'd you do, Madison?
I did the distributive property, and I did on the top, I did 7 and 7, and I drew a vertical line, and then I did 5 on the side, and then that is 35 and 35, which equals 70.
Nice. So, and what you did was 5 times 7 plus 7. Okay. So if you've never tried this, really try it. Now, I'm going to tell you right now, my exit ticket might be a little mean. I don't think it's really mean, but what I'm saying is if it takes you longer than 2 minutes, you don't have to stay on the meeting. You can leave and try it. But what I did is I make you go backwards. I give you the inside of the array and I make you find the numbers on the outside of the array. So I want you to tell me the multiplication problem that gives you that answer. But I want you to, tell me basically what's happening. So I think it's kind of a visual thing. All right, good luck with it. If you want to hang out here, I can go over more things. I have lots and lots of examples in my slides, okay, of these things. And you should be practicing a lot of them. But here's also my exit ticket if you want to see the QR code, because I think some of you use that. My goodness, where is it? There we go. I think it's a fun exit ticket. No, McKenna, you don't have to turn it in. So I'm here if anybody has questions too. I'm just going to be quiet so you can think.